Okay, this is handout 1, section 2.1. It's all about limits and continuity. I want to divide this section 2.1, into two parts. Okay, part 1, in today's class, we will focus our attention on limit. As a matter of fact, we already started in our last class the concept of limit, but those who are absent, maybe I will quickly go over that concept again in today's class. Okay. So this section 2.1 is divided into two parts. In part A, we will discuss about limits and we'll solve many problems related to limits. And in part B, we will focus our attention on continuity, which will be probably in our next class. Okay. So first, limit. Okay, here are the objective. Okay, here are the outcome. By the end of this unit, section 2.1, you'll be able to do these things: determine if the limit exists, evaluate limits by completing tables graphically and analytically, algebraically, find limits at infinitive, state the definition of continuity at a point for a function, determine if a function is continuous in its domain by using the definition, solve application problem related to limit and continuity. So these are the goal of this lesson. Now, first thing first, let's talk about limit. Like I said earlier, we talk about limit in our last class briefly, but again, I just want to, begin right from the beginning, because there are a few people absent in the last class. Okay, limits and intuitive approach. Informal definition. If the values of f of x can be made as close as we like to L by taking values of x sufficiently close to C, but not equal to C, then we write limit x tends to C f of x equals L, which reads the limit of f of x as x approaches C is L. What it means is, in this case, look at the figure. Here, as x approaches, this is x-axis here, as your x approaches C, maybe from this side, or as x approaches C from this side, meaning we are talking about, when x is close to C. Okay, when x is close to C, your y value, which is f of x, is, you see, close to L. This is called limit, and we write this statement as limit x tends to C, f of x equals L. Okay, so this is what it means. When x is close to C, then f of x is close to L. But the mathematical way of writing this is this. Now it begs a question when I say x close to C. Close from left hand is a very valid question. You see, when I say if x is close to C, then x can be this value, which is a little bit less than C. X can be this value right here, which is a little bit bigger than C. Now, for that, we have a special name for that kind of situations, okay? If I take my x value close to C, but on the left-hand side, which means a little bit less than C, then I call it left-hand limit, okay? So left-hand limit means when x is close to C but a little bit less, my y value equals L. We call it left-hand limit. And if I consider my x value, this one right here, a little bit bigger than C, which means on the right-hand side, then I can write that limit x tends to C plus f of x equals L. Okay, we define left-hand limit and right-hand limit that way. And then what we said in our last class is that if these two values are equal, then then we write limit exists and the limit is L. That's how we write. So in order for the limit to exist, left-hand limit and right-hand limit must be equal. If they are not equal, we say that limit does not exist. That's what we discussed in our last class. And this is one example that we did. Let us quickly do it here. Use the graph of y equals f of x in the figure below to determine the following limit. Okay, let's say x tends to 1. So when x is close to 1 from the left-hand side, it is 2, and from the right-hand side, still 2. So it means the approximate height of the function, approximate y value of the function when x is close to 1 is 2. So the limit is 2. What this means is, if I write limit x tends to 1, f of x equals 2, this means, let me write this way. This means two things. Limit x tends to 1 minus f of x equals 2. If you look at the approximate value of the y, approximate y value, when x is a little bit less than 1, still 2 as we have seen there, and limit x tends to 1 plus f of x equals 2. Therefore, if these two, because these two values are equal, we say that limit exists and the limit is 2. This is what we discussed in our last class. Now let's look at 2 quickly. Can you tell me what is the answer for that? You see, when you look at, yes.
3.
Yeah, 3, great. It's because when you look at this, x is approximately 2, but from the left-hand side, on the left-hand side, then we see that the height is approximately 3. And if you look at from the right-hand side, it's still 3, so they are equal. So we write limit equals 3. Even though f of 2 is undefined, remember this, f of 2 is undefined. When x is close to 2, the function is defined, and this is approximately 3. But when x equals to, okay, when x equals to, then the function is undefined. It's very important distinction between limit and the function, the value of the function at that point. When I say limit, I'm not talking about exact equal value. It may be equal, but we are not interested in that equal value, but we are interested in approximate value. That's very important distinction between functional value and the limit. Now, when x tends to 3, again, if you look at left side, it is approximately 1. If you look at right side, it is approximately 1 again. So the answer is 1. When x tends to 4, if you look at left-hand height, approximately 2. But if you look at right-hand height, it is approximately 3. So they are not equal. Therefore, limit does not exist. And in short, we decided to write D and E in our last class, right? Okay. Now notice that when there is a jump, okay, when the graph has a jump, then in that situation, limit does not exist. If the graph has little hole, limit exists. But if there is a big jump like this, then limit does not exist. And I think we did this as well. For the function f defined in the figure below, find the following. Limit x tends to 4. It's a left-hand limit. 4 means here, if I look at the left-hand limit, it is approximately maybe 6. And if I look at the x value, a little bit bigger than 4, it is approximately 2. Therefore, since this 6 and 2, the 6 and 2 are not equal, then we call it limit does not exist. And we did this as well. If you look at -5 right there, and if you look at the left-hand limit, it is approximately 4. If you look at the right-hand limit, approximately 4, the answer is 4. This one, can somebody tell me when x is approximately 2, what is the value? What is the limit?
3.
Yes, excellent, 3. Because if you look at a little bit on the left, 3, a little bit on the right, 3, therefore this is 3, even though the function is undefined at that point. Now let's look at when x is 0. When x is 0, right there, what is the limit? Anybody?
8. It's 8.
It's 8. Well,
8.
Any other people? What do you think? Let us look at left-hand height. If I look at left side, the height is 0. If I look at right side, yes, you're right. Maybe it is 8, or you can say 10, or, because the graph is going up there. So these two heights are different, you see. If you look at on the left-hand side and the right-hand side, these heights do not match. These values do not match. Therefore, the answer is D and E. Limit does not exist. Even though the left-hand limit exists and right-hand limit, depending on the situations, you can say infinitive, positive infinitive, but they are not equal, so limit does not exist. Let's look at 4. When x is 4, your left y value is approximately 0, right y value is also approximately 0, so the answer is 0. Now with this idea, I would like you to try 2 questions just for fun, okay? 2 practice questions. Did we do this practice questions in our last class, guys?
No, Professor.
Yes.
No, we didn't do them last class.
Okay, so let's try that. I know you can do it, but let's try this just for fun, okay? First, example 1. Okay, so you guys had a little bit for time to work on this practice questions 1. So let's check the answer. Consider the following function defined by its graph. Now, first in part A, we want to find the limit when x tends to -1. It is actually the left-hand limit at x approaches -1 from the left. So when x approaches -1 from the left, your height y value is approximately 2. And if you look at, x tends to -1 from the right, still the approximate height is 2. So the answer, the limit is 2. In the same manner, let us look at what is the limit for x tends to -4. So when x tends to -4, the left-hand height is approximately 3, right-hand height is approximately 4. So they do not match. There is a gap, there is a break, there is a jump in the graph. So the limit does not exist. And let us look at 4. So at 4 here, when x is a little bit less, which means the left-hand limit is -3, right-hand limit is -2. Okay, -2, -3, they do not match. So again, D and E. Thank you. And I want you to try one more just for fun again. Take a few minutes. Okay, you guys had a few minutes to work on this example too, and let us check the answers now, okay? Limit x tends to negative, x tends to 1. Negative on the top, it means left-hand limit. So x is 1. 1 is here. A little bit on the left-hand side, the answer is 3. A little bit on the right-hand side, is still the answer is 3. So therefore, this is 3, great. And when it is 5 or negative 5, if it is negative 5, left-hand height, left-hand limit is 2, right-hand limit is 3, so it does not exist. And at 5, again, the same thing, left-hand limit is 0, right-hand limit is 1, it does not exist. Okay, great. Do you have any questions so far, guys?
No, Professor.
No.
Okay, now the question, I think if you are given a graph, you can find out the limit by just looking at the graph, okay? If you are given the graph, but life is not that always easy, right? Sometimes instead of graph, they give us function or equation. Then how do we do that? Well, one way is to draw the graph of the function and then use the method that we just learned. But sometimes, you know, drawing graph of some function, if the function is like simple, let's say 2x plus 3 or y equals x squared minus 2, they are easy to draw. But if the functions are really ugly, something like y equals, let's say, ex squared plus 2 plus ln x minus 1, something like that, then drawing a graph of these kind of function is not fun, right? So how do we do that? We need to learn the technique now, and we will do that now, okay? As a matter of fact, there are 3 methods of finding the limit. One is graphical method, we have just seen. Another is numerical method. Another is algebraic method. Okay, 3 methods. And we'll do 1 or 2 problems using all of these 3 methods. And then out of these 3 methods, you tell me which method you like, and in the future, we'll follow that method. Okay, the method you find easy. Now, example 3. Evaluate limit x tends to 2f of x, where f of x equals x squared. It means that is what happens to f of x equals x squared when x is a number very close to but not equal to 2. That's the question. Okay, for these questions, let us use all the 3 methods. And you tell me which method you like, and I'll follow that method in the future, okay? So now method 1. Numerical method. So in numerical method, what you want to do is just draw a table. Okay. Remember, we want to find the limit of f of x at x tends to 2. Okay, when x is approximately 2, what is the value of f of x? That's what we want to find. In numerical method, what we do is, you know, this is, let's say, this is your 2. So we Remember in the previous example, we have considered the left-hand limit, means couple of values on the left-hand side, couple of values on the right-hand side from 2. Okay, so let me consider some few values from the left. So let's say 1.9, for example, 1.99, let's say 1.999, for example, okay? And then this is 2 and some right-hand value, maybe 2.001, okay, maybe 2.01 and maybe 2.1. Okay, couple of values. Now, I want you to use your calculator and tell me when x is 1.9, plug in that value here. So 1.9 squared, how much is that? Okay, thank you. I see your answer in the chat room. So this is 3.61, you said. And now for this one, plug in the value 1.99 squared. How much is that? I see that you got 3.9601 and 1.999. I see that you came up with 3.996. Okay, 4 digit I'm writing, 9960, something like that. When x is 2, then this is 2 squared 4. When x is 2.001, I see that your answer, you came up with 4.0004 maybe. No, 004. Okay, 004. And when it is 2.01, I see that your answer is 4.0401. And when it is 2.1, it is 4.41. Now notice that on this side, x approaches 2 from left on this side. Okay, so these are the value on the left hand side from, and here this side x approaches 2 from right. Right? And what we notice is in this side, f of x approaches 4 from this side and f of x approaches 4 from the right hand side as well. Therefore, so from the table, it is clear that limit x tends to 2 when x is approximately 2, whether I consider the values on the left from 2 or values on the right from the 2, my function value f of x is approximately 4. So that's how we do. This is called numerical method. Okay, what you need to do is consider a couple of values on the left hand side and a couple of values on the right hand side, x values, and then you plug in that value in the function and figure out where that function is heading to, okay, from both directions. Look at the approximate value where that function is heading to, and that will be your answer. Now let's look at method 2.
Excuse me, Professor.
Yes.
I have one question regarding the values of x we have took. Like we can take only the values which are very close to 2, like 1.9, or we can take the values like 3 or 4.
No, no, because remember, limit means it's approximate value. That's how we define the limit. You consider as close as possible. If you take 1.999999, that's even better. Okay. On the right hand side, if you take 2.000001, that's even better. But you know, that's sometimes close enough is good enough.
Okay, thank you, Professor.
Yeah, that's a very good question though. Okay, now method 2, which is a graphical method. So in graphical method, you just draw the graph of the function, okay? So here, graph f of x equals x squared. And I trust that everybody know how to draw graph.
Yes.
It is a parabola, opens up, right? So this is your graph. Now, the question is when x is, let's say 1, when x is 2, this is 1, this is 2. Now, we are looking approximate value when x is 2. This is your 2, this is your 1. We are not interested in 1, we are interested in 2. Okay, this is, let's say 2, this is 4, this is 6 here. Now, to find the limit graphically, you have done lots of exercise, practice questions before. Now, look at what is the approximate value on the left-hand side, which is 4, and from the right also, which is approximately 4. So from the graph, by looking at the graph of f of x, it is clear that limit x tends to 2, f of x equals 4. Okay, this is called a graphical method. Now let's look at algebraic method, method 3. Algebraic method. So limit x tends to 2, f of x equals limit x tends to 2, your f of x is given to be x squared. So in algebraic method, your first step is to plug in the value directly. Okay, you plug in the value of x directly. If it makes sense, if it is a defined number, if it makes sense, then that is your answer. Let's say 2 squared, which is 4. That is your answer. Sometimes, if when you plug in the value directly, if you get undefined value, let's say 0 over 0 or infinitive over infinitive, then in that situation, we can either use the algebra and we can use the L'Hopital rule. So that rule we'll be learning at the end of this course. But basically in this section, whenever we have the situation 0 over 0, like in the next example, then we'll be using the algebra, high school algebra, factorization, cancellation, whatever is possible, we'll do that, okay? But first thing, try to plug in the value directly. Most of the time you get the answer right away. Now, out of these 3 methods, which method do you like?
Algebraic method.
Algebraic method 3. Everybody agree on that?
Yeah.
Yes, Professor.
Yeah. All
Okay.
are good.
All right. So from now onwards, we'll be following, because our goal is to find the limit by using any one of the method unless otherwise stated, right? So you can use any one of these methods to find the value, to find the limit. But just for fun, we'll try one example by all of these three methods. And then after that, we just follow the algebraic method only, okay? Because I want you to know all of these three methods, but you can use one of them to solve later on. Now, example 4, it's very similar to example 3. I want you to try all of these three methods. Numerical method, I have already given here. So again, it is 2, so you will consider a couple of values. Remember, in the previous example, I just considered 3 values on the left, 3 values on the right. That should be enough. But if you want to consider 4 values on the left, 4 on the right, great, no problem. If you want to consider 10 values on the left and 10 values on the right, that's also fine. But I want you to consider at least 2 or 3 on the left, 2 or 3 on the right. That's minimum. But you know, if you want more, no problem.
Professor, example 4 is gonna be same as example 3.
Yeah, it looks like here it's undefined.
Because we're gonna take x square common from the numerator, and then the x minus 2 will get cancelled and we remain with x square.
Exactly. Okay, but remember here, the tabular value will be the same, except when x equals 2, the function is undefined. So here in the previous example, we had 4, but now in this case, it's undefined. That's one difference, right? And
Okay.
so by looking at the table, you can say that, you know, you can say that limit x tends to 2. Okay, this is numerical method, method 1, numerical method, f of x equals, now tell me, even though when x equals 2, the function is undefined, but where that, you know, f of x is approaching, this is 3.9999999. This is 4.00001. So you can say that it is approaching towards 4, right? Even though when x equals 2, it's undefined, but we can see from the table that both values are approaching towards 4. So the answer is approximate value of f of x is 4. Okay. Now, second method, so graphical. I want you to draw the graph of this function. Graph g of x equals x cubed minus 2x squared over x minus 2. So if you draw the graph, can somebody tell me whether its graph is the same or different from the previous question?
I think there will be hole at x equals to 2.
Excellent, yes. The graph will be the same, but you have this is 1, this is 2. So at this point, you have a hole in it, right? Now, if it is a hole, then the limit still exists, unless there is a big break or jump in the graph, right? So if there is a hole, then from the graph, you can say, by looking at the graph, we can say that limit x tends to 2, f of x is 4, because left hand limit, left hand height, or right hand height approximately is 4. Yeah. Now, method 3, algebraic. So limit x tends to 2, g of x equals limit x tends to 2, x cubed minus 2x squared over x minus 2. Now always try to plug in the value directly if possible. So if I plug in the value directly, what do I get? I'll get 0 over 0. So 0 over 0 is undefined. Okay, we call it indeterminate form. Now this can be solved by a couple of methods. One method is using simple algebra. Another is using L'Hopital rule. So there is a rule that we'll be learning at the end of the course, because for the L'Hopital rule, we need to know how to find the derivative of this function. So far we have not learned derivative. So we're going to use the high school, simple high school algebra. So whenever you have this 0 over 0 or infinitive over infinitive, you can use algebra. So the easiest algebra that you can use is, like somebody told earlier, you can take x squared common. So the remaining is x minus 2 over x minus 2. And this cancel out. Now try to plug in the value directly. If you get a meaningful number, you are done. If you still get 0 over 0 or infinitive over infinitive, do some algebra, okay? So here the good news is when you plug in the value directly, you get a meaningful number, you are done. That is your answer. So we have done this problem by all of the 3 methods. Now, as you said, still you like algebraic method more than others, right? So your mind has not changed yet. You still like algebraic. So from now onwards, I'll be using algebraic method. And sometimes maybe, graphical method or numerical method just for fun here and there, but most of the time I'll be using algebraic method, all right? Now, before we solve, we evaluate the limits, we need to know some limit rule. All right, so limit rule.
Hello, Professor.
Yeah.
Professor, in numerical method, if we change the statement g of x, means we take common x square from the g of x, then we put the value of x at 2, then value of function is defined.
Say again, what is your question?
Sir, in numerical method, at
Yeah.
x equal to 2,
Mm-hmm.
where if we change the statement g of x, we take the x square common from there.
Oh, no, don't take common. No. In numerical method, so numerical method means we are plugging x equals 1.9. Okay, not approximately 1.9. X equals 1.9. What is the value? X equals 1.99. What is the value? So we are talking about equal values for all of these. So when x equals 2, then this is undefined. So yeah, so you cannot do the algebra. Okay.
Okay. Thank you, Professor.
Yeah, thank you. Now, let's look at some limit rule, because if we decide to use algebraic method, then limit rule is required, because otherwise it will be difficult for us to evaluate the limits. So let us look at limit rule. When you have two limits, f of x and g of x, two functions adding together, so what you can do is you can distribute this limit to each of these functions, okay? We can write limit x tends to f of x plus limit x tends to a g of x. We call it sum law. In the same way, when f of x and g of x, there is a difference between these two functions with the limit, we can actually distribute this limit to both of these functions. Same thing, when there is c f of x, then we can write c. C means it's a constant. So if there is a constant multiplied or a function, then we can write that constant out and then write the limit with the function. Just keep in mind the function, the limit will always go with the functions, okay? If two functions are multiplied and there is a limit, then you can write this way and so on. Now, using that limit law, let's try example 5. Suppose limit x tends to 2f of x equals 3 and limit x tends to g of x equals 4. Use the limit rule to find the following limits. Okay, let's say part A. Limit x tends to 2 f of x plus g of x is squared. According to the limit law, what we can do is we can write limit x tends to 2 f of x plus limit x tends to 2 g of x is squared. We can write that way. Okay, you don't have to write, x tends to 4 by putting this limit inside. In the exam, I see that some people, what they do is they do this, limit x tends to 4 and f of x and plus limit x tends to 4 and g of x. When I ask them, how did you get that 4? They say that because, we are taking this 2 inside the square. And so I'm making this a square. This is absolutely wrong. You can't do that according to the limit rule, okay? This power law. Okay, so then we have the value. So limit x tends to f of x, we know that is 3. And this guy, limit x tends to 2, g of x is 4. So just plug in that value. And so your answer is going to be 40. That's it. Any question?
No, Professor.
All right. Now let's try this part B. Again, limit, what you can do is you can write that limit with the function and then limit with this function. Oh, it's ln means logarithm, natural logarithm, okay? You know that log x, you know ln x, right? So this is natural logarithm. So limit x tends to 2 g of x. So we can put that limit with the function g of x. Now you can plug in the value. Limit x tends to 2 f of x. We already know that is 3 squared. And then the bottom part is 4 ln. And this guy inside is 4. So your answer is 9 over ln 4. And if you want to simplify it using calculator, then you can tell me the answer. Otherwise, you can just leave it just like that. You don't have to change it. All right. Do you have any questions so far? Okay. If no, then
Professor,
yes, go ahead.
why are we adding link in the bottom? I mean, just beside the 4.
Why we? Okay, so this
Why
in the
in the limit
question,
like beside the 4, number 4?
in the question there is this question, right? Ln g of x.
Oh,
I just copy that ln as it is. So this limit, I put it with g of x. Remember the limit according to the limit law, we need to put that limit with the function f of x, g of x, h of x, whatever the function is. And
okay.
so I put that inside and yeah.
Oh, okay. Got it.
Okay. All right. Okay. Now let's take 10-minute break. So we said that you all said that algebraical method is easier compared to other one, and you like that. That's okay. Now here are some strategy to follow. Okay. What I said earlier is that try to plug in the value of x directly into the function. If it makes sense, if you get a meaningful value or meaningful expression, meaningful number, you are done. But if you get 0 over 0, infinity over infinity, we call it indeterminate form, then there are two methods, there are two ways we can evaluate the limit. One is by algebraic manipulation, okay? So what we did in the previous example is that we factorize it and we notice that one factor can be canceled, and then we cancel that factor and then we plug in the value, we got the answer. Okay, that's one way. Sometimes that is not possible. You cannot factorize, you cannot do any algebra. So in that case, we will be using the L'Hopital rule, and like I said earlier, we'll do this at the end of the course. Now, example 6, let's try a few of the questions here, okay? Let's try from part A. Limit x tends to 4 is square root x. So what you do is you first plug in the value directly if possible. Yeah, we got it. Okay, 2, that's it. Let's try part C. Limit x tends to 2, x squared plus x minus 6 over x minus 2. Now let us plug in the value directly. That's the first step you always do, okay? Try to plug in the value directly, if possible. If I plug in the value directly, I'm gonna get 0 over 0. Okay, so it tells me that I have to do some algebra. So now do some algebra. Algebraic manipulation is required.
We can factor the numerator.
Exactly. Okay. So if you factorize it, you're going to x minus 2 times x plus 3 over x minus 2. I trust that everybody know how to go from this step to this step. Okay. If you don't know how to go from this to this, that means you need to review your high school concept. You still are not ready yet to begin the calculus course, okay? But I trust you that you already know. This cancel out. Now plug in the value. If you get a meaningful number, you're done. Otherwise, you do the algebra again. So the good news is you plug in the value, you get the answer, that's it. Now let's try. Again, you can do this by, numerical method. You can do this by graphical methods, but I think algebraic method is much easier compared to others. That's what you said. So I'm following this algebraic method. Now let's try maybe part Z.
Yeah.
Okay, guys, I want you to try this part Z. The question is limit x tends to 16 is square root x minus 4 over x minus 16.
Professor, will we write x in?
Say again.
We should write x in the denominator as square root x and 16 as 4 square. And then we should use x square minus 4 square.
Great, yes. Okay, you already got it. So if you plug in the value directly, you're gonna get 0 over 0. So that means we have to do some algebra, and the easiest algebra would be, you can do this way. Because x means we can write x minus 16 can be written as square root x square minus 4 square, right? So it means you can write square root x minus 4 and square root x plus 4. So because this is a square minus b square formula, so that means a minus b times a plus b. So we can write that. And this cancel out. Now plug in the value. If you get a meaningful number, you're done. Otherwise, you have to do some algebra again. So the good news is 1 on the top. And so you have 16 plus 4, which gives me 1 over 8 is your answer. Now, let's try. Well, this can be done by another method as well. Can somebody think of how we can do it? X tends to 16 is square root x minus 4 over x minus 16. I think in high school, in high school algebra, you have done something like multiplying by the conjugate. So you multiply by square root x plus 4 over square root x plus 4. So the opposite sign of that in order to rationalize, okay? That's the method that you use to rationalize. So if you rationalize it, you can do this as well. So that's, that's method 2, I would say. And so you can write this as limit x tends to 16. Remember one thing, that until and unless there is x, you must keep on writing limit. Okay, limit x tends to 16. Now on the top we have x minus 16, and on the bottom x minus 16 times square root x plus 4. This cancel out, and now you still get the same thing, 1 over 8. So you can use any one of the method.
Professor, I have one question.
Yes.
When we...
So part H is limit x tends to 8, 1 over x minus 8. Can you try this? Okay, in this case, when you plug in the value, you're going to get 1 over 0. Remember, 0 over 0 is indeterminate form. Infinitive over infinitive is indeterminate form. 1 over 0.
Sir, we can add 4 and minus subtract add denominator.
Yeah, so no matter what what process you do, then it will not, I mean, you cannot use the algebra here, right? So you cannot factorize it. Rationalization is not a question here. I mean, you cannot, it's already rational function. So no rationalization is required. So we can do nothing actually. So what we notice here is that we'll get 1 over 0. What does that mean? It is infinitive. Okay, you just write infinitive. Or you can say undefined. That's your answer. Okay. I want you to try one more questions, okay? Extra question. Let's say FZHI. I remember one interesting story, one interesting jokes. Can I tell you a joke?
Yeah, Professor. Yes, sir. You can.
Okay. In the quiz, in the test, I gave one question in the previous semester. The question was this. And one of the student answer was, he wrote this answer. This is his answer. And I was surprised. When I see this answer, I was surprised. How come he wrote 5, I mean, this, and then I decided to talk to him, and I said, I invited him to the Zoom, and I asked him, okay, how did you get that answer? Well, I just did the way you did, because he didn't get, I gave him 0, okay? So these questions, I gave him 0. It is not correct. But it was interesting, and I wanted to know. And he told me, why did you give me 0? Because I did exactly the same way you taught in the class. You taught that if limit x tends to 8, 1 over 1, x minus 8 is, 8 is there standing, and what you did is you make it sleeping. So you just make it sleeping head, right? You just do it that way. And I did the same thing here. And you didn't give me the answer, mark. Well, it's interesting. Keep that in mind, okay? It's not just making it sleep. It has a... All right, so let's work the last question, part I. Limit x tends to 0, 1 over x minus x over 1 over x minus 1. So how do you do that? Well, if you plug in the value, you're going to get 0 over 0. So maybe you can do some algebra. So you can think of what algebra comes to your mind. Maybe you can do this, you know, a little bit of this high school thing. You will get 1 over, you know, this x, you will get 1 minus x squared over x 1 minus x. So on the top you have 1 minus x squared over x. Now you need to flip it, so x over 1 minus x. And don't forget to write the limit. And so you can cancel this x. And now you have 1 minus x times 1 plus x on the top, 1 minus x on the bottom. This cancel out. So you can put it and the answer is 1. Any questions so far?
No, Professor.
Okay, so the remaining questions, I think I trust you that you can do it, but if you need help, then look at my lecture note, and I put all the solution of those questions. Now we will be talking about limits at infinity. So what does that mean, limits at infinity? What it means is, let's say I have a function here. This is my f of x. Remember, limit means it's approximate height of the function, right? Approximate height of the function. If I ask you limit x tends to infinity of f of x, what I'm asking is that when x is, x goes to infinity, what is the height of the function? Now the question is, we don't know where that infinity is, right? So x is going to infinity, you go to infinity and you measure the height of the function. Is that possible? That is possible in mathematics. That is the power and beauty of mathematics, you see? So I'm asking you to go to infinitive, okay? Not here, not there, not there. So go to infinitive, that direction, and you measure the height, approximate height. And your answer, you can tell me this function, your answer is 1, right? Because this is called asymptote, horizontal asymptote. So when I say limit x tends to infinity of f of x, I'm asking you what is the horizontal asymptote. This gives us the horizontal asymptote, okay? So now the question is, if we are given a function in a graph, we can tell the approximate height easily, but sometimes they don't give us the graph, but they give us function like this or the expression like this, okay? How do we do that? That's what we're gonna do. Now, before we do this, let me take you to elementary school just for a few seconds, if you don't mind. Now, tell me, k is a constant. So k times 0 is what? 0?
0.
Any number multiplied by 0 is 0. 0 divided by k is what? 0. K divided by 0 is what?
Not defined.
Not defined, and we write this infinitive. And if I ask you what is the value? K divided by infinity, what is that?
Do not exist.
0. 0. Okay, I want you to remember this from your elementary school. And now let us come back to the college math, okay? So remember, anything divided by 0 is infinitive. Anything divided by infinitive is 0. We need to know that. We need to recall that from elementary school. Now let's come back to this question. There are a couple of ways to do this, guys. I'm gonna do this, the method which is given, which is generally used in solving this kind of problem, and I'll give you another method and you tell me which method you like. part A. Limit x tends to infinity, 2x squared plus 3x minus 4 over 6x squared minus 5x plus 7. If you plug in the value, you're going to get infinity on the top and infinity on the bottom. Agree? Everyone agree? So what is that? Can I, let me ask you one thing. 2 divided by 2, how much is this?
1.
1. X divided by x, how much is that?
Still 1.
Infinity divided by infinity. Can I write 1?
No.
No.
Okay, that's a good observation, guys. We cannot say that is wrong. Because there are different kind of infinitives. Some infinitives are smaller than others. Some infinitives are bigger infinitives. Okay, infinity is actually different kind of infinity. We'll do that in your advanced math course. But at this time, so at this time, what we want to do, what you need to remember is that infinity over infinity is called indeterminate form and it is undefined. Now, one method to solve this, to evaluate the limit is this. You divide each term by the highest power of x from the denominator. Denominator means the bottom part. So figure out what is the highest power in the denominator. That is x squared. So you divide everything by x squared, okay? Limit x tends to infinity, 2x squared over x squared plus 3x over x squared minus 4 over x squared over 6x squared over x squared. Now the question is, can we do that? Now let me ask you, suppose you have 5 over 7. Can I do this 5 divided by 2 and 7 divided by 2? Can I divide top and bottom by the same number? Is that okay? If you
Yes, it is.
Yes, we can do that, right? So that's what I did. I divided everything on the top by the same quantity and in the denominator by the same quantity. We can do that. Now, if I simplify this, what I get here is that the first part will be 2. The second part will be 3 over x minus 4 over x squared over 6 minus 5 over x, 7 over x squared. Now let us plug in the value. If we get infinity over infinity or 0 over 0, we have to do some technique, but if we get a meaningful number, we'll be done. Let's see. If I plug in the value infinity, I'm gonna get 2 plus 3 divided by infinity. How much is that?
It's a super small number.
0.
0. Remember what we said earlier, somewhere here? We recall from our elementary school that anything divided by infinity is 0. Okay, anything divided by infinity is 0. So that means this guy will be 0. This guy also will be 0. And 6 minus this guy will be 0. And this is 0. So your answer is 1 over 3. Done. Now, let's try one more just for fun. Idea is the same. Let me try part C. Limit x tends to infinity, 2x cubed minus 3x squared plus 1 divided by x squared plus 2x plus 4. Now, if you plug in the value directly, notice that you're going to get infinity over infinity. So that means we have to do some algebra. And the algebra that we decided, this is the strategy, this is the technique that we'll be using. We divide everything by the highest power in the denominator. So that means we have to divide by what? X cubed or x squared?
X squared.
Because highest power of x from the denominator, not from the numerator, okay? From the denominator, which is x squared. Divide everything by x squared. And that's going to give me limit x tends to infinity. The first part will be 2, first term will be 2 over 2x, or simply 2x, minus 3 plus 1 over x squared over 1 plus 2 over x plus 4 over x squared. Now let us plug in the value. What do we get? Do we get 0 over 0 or infinitive over infinitive? If we get that, then we have to think about some technique. Otherwise, we'll get the answer. If I plug in the value there, I'll get 2 times infinitive minus 3 plus 1 over infinitive square, which is 0, over 1 plus 2 over infinitive, which is 0 plus 0. Now, this is not in any one of these forms. So your answer is going to be 2 times infinitive. How much is that? Is it 2 infinitive or simply infinitive?
Simply infinitive?
Yeah, simply infinitive. And infinitive minus 3. If you subtract 3 from infinitive, what do you get?
Still infinitive?
Okay, so I can write simply infinitive. All right, so that is your answer. Or you can say undefined, because infinitive is undefined value. In the same manner, you can do part B and D, but I told you earlier, let me show you another method. And you tell me which method you like and you follow that, okay? Method 2, part A. You know, this method 2, it's not given in your textbook. It's not given in general, it's not given anywhere, but this method is really handy. Most of my students in the past, they like this method, but I want to ask you which method you like and we'll follow that method, okay? Now I call this method forget the little one. Forget the little one method. What it means is you forget the little one. Think of this situation. Let's say, you know, you have a, you know, 2 company, okay, company A and company B. Now, if these 2 companies wants to make some kind of agreement, okay, some kind of agreement, do you think that every single person working for that company and every single person working for that company come together, sit together, discuss and figure out what will be the policy or what will be the agreement? Generally not. What they do is the leader, the CEO or the leading, you know, the team of the leaders, they come together, they sit together, and then they decide what the policy or what the agreement will be. Same thing with country. Let's say country A and country B. Let's say Canada and India, for example. If they want to make some kind of agreement, do you think every single person from Canada, every single Canadian citizen, every single Indian citizen, they sit together and then discuss and figure out what the policy will be? No. Okay, what they do is they just, you know, the leaders, they sit together and they figure out. So that's what I'm saying. Forget the little one. You just talk about the leaders here. So let me, in this part A, the leader means the term with the highest power. In the numerator, okay, in the numerator, the term with the highest power is, let me just copy that question first. This is 2x squared plus 3x minus 4 over 6x squared minus 5x plus 7. Now, the term with the highest power is called the leading term. That means the leading term is this in the numerator, 2x squared. Invite the leader and invite the leader from the bottom. So leader from the leading term is this, because this has the highest power, 6x squared. Okay, you just invite the leader from the top, invite the leader from the bottom, and you put them together, and they will decide what the answer is. Done. Okay. Now let's look at part B by using that method. In part B, limit x tends to infinity, 100x plus 50 over x. Now invite the leader. So leading means here the x power 1, here x power 0. So the leader means the, the term with the highest power, which is actually 100x is the leading term on the top, and x in the bottom is the leading term. So you invite them together, they put them together, and they will decide what the answer is. Done. Let's try part C using the same method. And here, limit x tends to infinity, invite the leader. So the leader is, as you can see, this is the highest power term with the highest power. We invited the leader, and this is the highest power in the denominator, that is the leader in that bottom part. Invite them, and you put them together, and they will decide what the answer is. 2x. So then we can do no algebra here. Your answer is simply infinitive. So which method do you like, by the way?
Forget the little one.
Okay.
Second method.
All right. So you choose whichever method you like. No issue there. And you may want to try the remaining part D yourself at home. If you need help, then there will be solution. Now the last questions, I think I have 10 minutes. And if we do this example 10, we'll be done with this part A. Okay, so let's complete this. Limit of a piecewise function. So far, we deal with limit of non-piecewise functions, okay? But when we are given a function which has two pieces, let's say h of x equals 2x plus 2 when x is less than 1, 2x minus 4 when x is greater than or equal to 1. So in that case, how do we evaluate the limit? So we need to evaluate limit x tends to 1, h of x, and limit x tends to 3, h of x. So we want to do this too, okay? It says numerical, graphical, algebraical method, but I want to try just the, you said that algebraical method is the easiest one. Maybe I'll go for algebraical, and numerical and graphical, I'll leave it to you, but I'll provide the solution in my lecture note. Example 10, part A. Limit. So remember, guys, when the piecewise function is given, then I strongly recommend you to use this left-hand limit and right-hand limit approach, because there are different pieces. Sometimes on the left-hand piece and the right-hand piece, they may not be equal. So in that case, it is always better to use this left-hand, right-hand approach in order to evaluate the limit for the function, for the piecewise function. So part A, let me just copy the question. This is the question, okay? In order for that, what we do is we find the left-hand limit. First thing, you find limit x tends to 1 minus f of h of x. Find that. And then limit x tends to 1 plus h of x. Find that. And then see whether 1 and 2 are equal or not. Let's see. Limit x tends to 1 minus. Now, the function is when x is a little bit less than 1. Is that the first piece or the second piece? Look at the function and tell me.
First one.
First one, because x is greater than 1 means when x is a little bit less than 1, then we must consider the first piece. So first piece will be 2x plus 2. And so I'm going to get 2 times 1 plus 2, which is 4. Now, when x is a little bit greater than 1, the first piece or the second piece?
The second one.
Second piece, because x is a little bit bigger than 1 means the second piece, as you can see here. So that means 2x minus 4. That's going to give me 2 times 1 minus 4. That's going to give me negative 2. Okay. Then, as we have seen, left-hand limit and right-hand limit are not equal. So what is your answer?
Limit does not exist.
Excellent. Limit x tends to 1 h of x does not exist, D and E. That's it. And let's try part B as well. I want you to try part B. That is the last question for today, okay? So the question is limit x tends to 3 h of x. Find this. That is the question. Now, like I said earlier, you consider the left-hand limit and find the right-hand limit and see what you get. Okay, guys, you already got the answer, which is 2, but let me show you how you got 2, okay? X is a little bit less than 3. Little bit less than 3 means it must be the second piece. Because we are talking about very close to 3. So the second piece is limit x tends to 3 minus 2x minus 4. And then plug in the value, you're going to get 6 minus 4, which is 2. And here limit x tends to 3 plus. And when it is a little bit bigger than 3, it's still the second piece. So we got 6 minus 4, which is 2. Therefore, your limit x tends to 3, h of x equals 2. That is the answer. All right, guys, we are done this part A of this section 2.1, which is about limit. In our next class, we'll be talking about continuity.